Okay, we are moving on to review page 1C. Again, I'm going to give you some of these answers and some of them I'm going to work out. I would suggest you do the problems first and see if you end up with the right answer. Okay, so coming out of the gate, number 4 here, straightforward would be A. Number 6, if you do that, you should end up with an answer of 1/2. Number 7, that would not be on the calculus exam. If you wanted an answer, the answer is B, but that's not really a calculus problem per se. Let's keep moving on here. Number 9, you should be able to do. You're moving that the squared out in front, the power out in front, and finding the first derivative, and should end up with an answer of A. There. Number 11, I did want to go through. I think 11 would be a good one to kind of take another second or two on. 3x minus 4y is tangent in the first quadrant to the graph. Y equals x cubed plus 4, or x cubed plus k rather, and then k is what we're trying to figure out. Okay, and so you can kind of, if you wanted to kind of get a visual on that, we have some sort of graph here. Y equals x cubed is, kind of flattens out there, and then we have some sort of a tangent curve there in the first quadrant, and we're trying to figure out that k value. Okay, that's just a rough sketch there that it might look something like that. Okay, so anyway, back to the problem here. This is equivalent to y equals 3/4 x squared. So if you subtract the 3/4 x, y equals 3/4 x. That's what that is equivalent to, or the slope there is 3/4 is kind of the biggie there. That's the slope of the tangent line, and that's slope of the curve at that instantaneous point. Okay, so the slope over here would be 3x squared. Okay, that's a slope function for the entire function that would give you the slope at any point x if you wanted to put that in there. Okay, so we have this slope here, we have this slope here, that we're going to put those two together. Those have to match up. So we're going to say 3/4 equals 3x squared. And if you solve that, you should end up with x equal to 1/2. Okay, so that's your x value. Okay, we're trying to figure out k though. That's your x value. We're trying to figure out k. You could plug that in. Now it's just kind of plug and chug time. If you take that 1/2, plug it in that original equation for x, you get 3 times 1/2 minus 4y equal to 0. Y is going to equal 3/8. Okay, go ahead and plug that then. We're trying to figure out k. So what do we have here? We've got the x value. We got a y value here. We're going to figure out k. We're going to put that into that beginning equation up here. Okay, so you should end up with 3/8 equals 1/2 cubed plus k. You'll end up with a k value of 1/4. So just kind of breezing through that. But when it starts talking tangents, you just know you got to start taking some first derivatives. Would be kind of the first hint on how to attack that problem. We said that answer is going to be 1/4. There. Number 26. Let's take us a second to go through that. Radius of a sphere. This is your related rates. Okay, we're going to try to transform or translate those English words into math sentences or math equations there. Radius of a sphere is increasing. We can do that. I'm sorry. Let's erase that. We're going to write dr dt. dr dt equals 0.3. at the instant when the surface area becomes 100 pi, so that's going to be surface area equals 100 pi. What is the rate of increase of volume? So we're trying to figure out dV dt equals question mark. Okay, so I always just try to translate the English into math symbols, and now I'm going to do some calculus. Okay, so I have a volume here, then I'm going to take the first derivative and get dV dt equals 4 pi r squared dr dt. Okay, feeling good about that. I got to put in my dV dt. Okay, I don't have dV dt. That's what I want to figure out, so that's fine. That's my variable. I want to figure out 4 pi r. I do not know. At this particular time, I don't have a value for r. I have dr dt, so that's good. I got to figure out r. Okay, we can figure that out. They give us this other equation that we can use. Surface area, I can put 100 pi in there, equals 4 pi r squared. Okay, so there's got to be some way to figure that out, and you're going to end up with an r value of 5. So that's going to go in there for that r. 5 squared dr dt is right there. It's 0.3. Okay, and so you're on your way there. You just got to figure that out, and that's going to end up giving you 30 pi as a final answer. Typical problem. You've done these problems in class. So just keep your wits about you. You can do fine on that on the test. Let's move on to the page here. Okay, we're moving on to the next page here, the review. We're at 1D. And same scenario here. First problem, you're finding the first derivative. And it's going to be a lot easier on that first problem if you use a trig identity first. Give you a little hint there. I'll let you do that. But there is going to be a trig identity that you can use there. It's going to make it a lot easier, or at least save a couple steps. You should end up with an answer of C. 23, you're going to probably rewrite the original problem as x to the negative 3 minus x to the negative 1 power. So x to the negative third power minus x to the negative 1 power plus x squared. And find the first derivative of that. You should end up with an answer of negative 4. 26, your answer is E. That's one of those that's not really a calculus problem. That was on an old test, but they no longer put that type of problem on the actual AP exam. So it's going to cross it out there. And keep on cruising on through here. 31, should be able to do this. This is another one of those related rates problems. I'm going to give you the answer here as 24 pi. And then moving on to number 8, kind of a thought question. They like putting kind of these theory or thought questions in here. If a function has if f is a function such that the limit is this, okay, so you have this limit equal to 0. The idea is this function here is really a slope function. Sorry about that. Let me erase that. It's y2 minus y1 over x2 minus x1. That's just a slope function. So you're talking about slope as you get closer to a particular x value equal to 0. That's the definition of the first derivative. Okay, and so your answer there is C. And then number 9, that would be your implicit differentiation. Okay, you should feel confident about that. Take your time, talk, as you're going through the problem, talk yourself through it. Just make sure you're doing this correctly. You should feel confident about that as a double check. Every y in that original problem should lead to a dy dx in the next step. And that answer for number 9, I have down as negative 4/3. All right, and that should end up section 1.